Hi, in this short video I'm going to go over some essential Unix commands. This material is not really core to discrete math per se, but it's important that you master these commands to make life easier for yourself both in this class and for the rest of your careers in computer science. Every good computer scientist should know how to get around on a Unix in a Unix-like terminal window, and so here we go. I'm going to go over the set of key commands that I want to cover today on a slide, and then we'll cut over to a terminal window and do a little practice on our own. So here's the set of commands that I'd like you to get to know. You already know some of them. So ls lists the files at a given path. If the path is a data file, it just prints out the name of that data file. If the path is a directory file, then it prints out the list of a list of the files that are contained within, or children, if you will, of that directory. Now, many Unix commands take optional arguments in the form usually of dash followed by some letter. And that dash followed by some letter, dash says here's an option. Sometimes it's dash dash. But dash says here comes an option, and then the letter or set of letters or words sometimes that follow the dash indicate which option to turn on. A good example of this is the use of ls space dash l. The dash l means give me a long listing, and what that will cause the ls program to do when it's run is to print not just the name of the file, but some additional information about the file, such as its size in bytes, who has access to the file, we can get into that more later if you wish, and other pertinent details such as when it was created, when it was modified, and so on and so forth. Okay. Give it a try. The pwd command is another command that you should already know. It will print out for you as a string the shell's understanding of what your current working directory is. And you've seen that we can also use cd as a command to the shell, really, to the shell program to change the current working directory. Now, here's a command that you don't know. cp is short for copy. Many Unix commands are kind of cryptic 2-letter, 3-letter commands. And the reason for this is people just don't want to have to type a lot. So this was before windowing systems gave you shortcut keys. Very short command names were the trick to keep from having to type very much. So a lot of Unix-like commands have very short names. cp is the command to copy one file to another. So you say cp space a path to the first file space a path to the second file. Now the paths can be absolute or relative or a mixture of the two. Okay? If you don't remember what absolute and relative paths mean, go back to the video on paths, and you'll also get some practice using these ideas in the exercises that are coming up. Okay. Whereas the cp command copies one file to another, the mv command, short for move, moves one file to another, which is to say it renames the file. Okay, so if I have a file called foo and I want it to have the name bar, I could say mv space foo space bar. And as long as there's not already a file in that directory called bar, that command will rename foo to bar. Now the paths don't have to be in the same directory. So if I wanted, for example, to move the foo file in my current directory to live in the directory one level up, I could say, well, what? Move mv space foo space, and how do I talk about that directory one level up from where I am? Dot dot. So move foo dot dot would move that file without renaming it up one level. If I wanted to move the foo file up one level and call it bar in its new directory, then I could say move foo dot dot slash bar. Okay, and that would move the file currently at the path foo in my current directory to be the file bar one level up. So again, we'll see examples of all of this when we crank up a shell program in just a couple of minutes. To remove a file or delete a file, the command is rm. So you use rm space and the file name. Rm space foo, for example, will remove the file called foo if it exists in my current directory. if I say rm space /homes/user/bob/foo /homes/users/bob/foo, as long as I have appropriate access to that file over in Bob's home directory, that command will remove that file. So you can use either a relative or an absolute path name in all cases when you're issuing Unix commands. Now, one interesting question is, how do I create files on a Unix file system? And really, there are two cases. One is, how do I create and then delete directory files? And how do I create and manipulate and ultimately delete data files? The commands for creating and removing directory files are called, we pronounce them makedir and rmdir. Okay, so make a directory, remove a directory. Make directory takes a path, a name, and creates a directory with that name at that path. There's a little constraint here, which is that all of the directories in the path leading up to the directory being created have to already exist. But if you want to kind of create a new directory several levels down inside of a path that doesn't already exist, you can say makedir space -f for force space and then a path, and the system will create a path all the way to that file, even if the intervening directories didn't already exist. rmdir is the command for removing a directory, but the constraint here is that that directory needs to be empty. So what if you wanted to remove a directory with hundreds of directories inside of it, each containing thousands of files? Well, you certainly don't want to have to go in and remove all those files and directories by hand. So a command is rm for remove, -r means recursive, so go from the given path and to all files below it. rm -rf, the f means force, so don't give up if you find a non-empty subdirectory. Just delete an entire directory and all of the paths underneath it. So rm -rf or -rf space and then a path will remove all the files at and below a given point in your file system. Now the command echo seems sort of silly at first, because all it does is take a string as an argument and print out that string on your console, in your terminal window. But Bash and other shell programs have all kinds of interesting ways of interpreting special strings to mean certain things. So you've already seen an example where, for example, tilde means my current working directory. So give it a try. If you say echo space tilde, then the shell, before executing the echo command, will expand tilde into your current working path and current working directory path, and then print out that current working directory on the screen. So good. Now the shell keeps track of a lot of information on your behalf. It not only keeps track of your current working directory, but of many other what we call environment variables. Okay, when we talk about environment variables, we talk about variables whose values are maintained by the shell program for you. One of those programs is called path, and the way to expand the value of an environment variable into its corresponding string value in a shell program is to prefix the name of that variable with a $sign. So if I say echo $path, once again, the shell will expand the path variable into its value. That's what the preceding $sign means. You'll get the path to your current working directory, and then echo as a string, and then echo will print out that string. So echo is a great command for printing out the values of individual environment variables. Now, if you want to see all of the environment variables that your shell is currently maintaining for you, you can use the printenv command. And you might be surprised at how many pieces of information your shell keeps track of for you. There are ways of setting, changing the values of, and removing environment variables from your shell's environment. An environment here being a funny word for a binding of variable names to values. Okay, so you can print out, manipulate, change environment variables, and then many programs actually read the values of environment variables that are passed to them from your shell when it executes those programs, and then they can behave accordingly. So environment variables are an important mechanism in Unix machines for communicating information from a shell to programs that shell executes on your behalf. The most interesting and important intellectual construct on this set of slides is this notion of an environment. And again, an environment is a binding of variable names to corresponding values. In the case of shell environment variables, these values are string values of one kind or another. Okay, we'll see this concept of an environment coming back later in this course when we talk about defining the syntax and the semantics of formal languages in a proof assistant like Lean. It's a key concept in the areas of programming languages and compilers is the notion of an environment. Okay, so let's transition over to a terminal window here. I can find my mouse pointer. And we will have a quick look then at how some of these commands play out in practice. So here we are in a standard terminal window. I'm just hitting enter a few times to show you that I'm here and active. I'm going to use the clear command to clear up my screen. And I'm going to start off here. I see that I'm in a directory called ~pers. That's because I was working on a project. If I want to see the files in this directory, clearly I can do ls. If I want more information about these files, I can do ls-l, and you can see that for each file I get quite a bit of information. The first block of information tells me whether I'm looking at a directory or not. A directory file is prefixed with D here, or a data file has no D. Then the remaining part of this chunk of information tells me for the owner of the file, for the group to which the owner belongs, and for anybody else using this machine, what rights they have to access this file. Read, let's see, read, can somebody read this file or not? Can they write it? Can they change it? And if it's a program, can they actually run it or not? That's the execute command. So we have three 8-bit let me cancel that. We have 3 different levels of protection for files on a typical Unix machine: owner, group, and world. Okay. Here, the one here is the current group to which I belong. It has no interesting name, and usually you don't have to think about what groups you're in on a Unix machine. Sometimes you do, but not at this level. Here's my username. That's the owner of the file. Actually, no, the one here is not the group. This is the group. Let's just ignore that. We have an indication of how many bytes of information are in each of the files. How many bytes? So we could say that this file is 122,056 bytes. That's roughly 122 kilobytes of information. Okay. Here's the time at which, the date and time at which the file was created, and the name of the file in my current directory. Okay, so for each of these files, I get some more information. Now let me tell you one more option for the ls command, ls-l, and if I put an R here, that tells the machine to print out all of the files in the current directory and to recurse into and print out the files in subdirectories all the way down to the bottom of the tree. So you can see that I got much more information here because I have a lot of things going on in this directory. Okay. So we know how to change paths. That's CD. Here's a little piece of information that I didn't give you before. If I want to change to my home directory, I can do cd space tilde, but the default path for the cd command is my home directory. So if I just do cd all by itself, that's a quick and easy way to to have my shell change the current working directory to my home directory, which here you now see in the command prompt as just a tilde. Okay, so if I do pwd here, you can see that my current directory on my Windows machine is /c. That means the Windows file system on the C drive /users/Sully. Okay, so Sully, my name within the set of names of users on my machine. Okay, good. So an important command is well, let me skip ahead just one command. I want to give you a set of examples, show you how some other commands work, but I want to do that in a little private directory. So I need to make a directory here. I need to create a directory. The command for creating a new directory is called makedir. Okay, makes a directory. And I'm just going to call this directory 2102 temp. Okay, good. So I just created a directory called 2102 temp. If I do ls-l 2102, here's another trick. If I partially complete a file name and then hit tab, as long as I've given enough letters to uniquely identify that file name, hitting a tab will complete that file name for me automatically. It's a real time saver when you really get zipping along using your terminal window. Okay, so I'm doing ls-l to get a long listing for the file. Well, 2102 temp is a directory, so the ls command shows me the files within that directory, of which there are none. If I want to get information about that directory file itself, I need to tell ls to give me information about the directory file itself, not the files inside of it. So the -d option does that. And I can see now, for example, that the creation time of this file is 12:49 afternoon on September 7th, which of course is just right now relative to when I'm making this video. Okay, so now let's cd into that directory, 2102/temp. Good. Now if I do an ls in here, there are no files in this directory. There are no files in this directory. Okay. So suppose I made a mistake and called that directory something that I didn't want to call it. I could rename it. Now, to do that, let's go back up one level. Okay, you can see I'm currently in my home directory's 2102 temp directory. When I say I mean my current working directory is that directory. If I go up one level, then I'm back in my home directory. The rm command is used to remove files on a Unix machine, but it doesn't work for directories. It works for data files unless you give it some additional options. So if I try to remove 2102 temp using rm, it says, sorry, I can't do that, it's a directory. Okay, the command to remove a directory is rmdir. So if I rmdir remove directory 2102 temp, why that works. And if I now look for 2102 temp as a file in my current directory, there is no such file. Let's make the file again. We'll just, okay, 2102 temp is fine, so we'll remake that directory, 2102 temp. Good. Now I'm going to go into this directory, 2102 temp. And a command that's not on the slides, let me just tell you, if you use the command touch and give the name of a file, like, I don't know, foo, for example, that will simply create an empty file called foo. If the file already exists, what the touch command is, it updates the time at which that file was modified. Okay? And modification times of files are sometimes important. So the touch command. So at this point, I have a file called foo in this directory. Now let's see what happens if we go up one directory and try to delete the 2102 temp directory. rm doesn't work, but rmdir is a command for removing directories. Now I try to remove 2102 temp, but it doesn't work because the directory is not empty. I could go into that directory and remove foo, or I could say remove 2102/temp 2102 temp / foo, and that would work. Now that directory is empty, and so the rmdir command will work once again. Okay, let's make that directory one more time. Make dir 2102 temp. Okay, now we'll go into the directory. Let's not go into the directory. Let's just use touch, and we'll use a path name here, 2102 temp / foo. We'll create that file at that path. Remember, that's a relative path. We have /user /sully /2102 temp / foo. That's the file that's going to be created. We're using a relative path name here. If I list the 2102 directory, well, there's that foo file in there that we just created. Now suppose I want to remove this directory without having to go through the bother of removing all the files that are in the directory. Again, rmdir is not going to work. The command that you want here is rm -r for recursive. And a second option, you can string these options together with the rm command. The F option says force, it means do it even if you otherwise wouldn't. Okay, and now I can give the directory name 2102 temp, and this will remove that directory plus any files in that directory, including recursively subdirectories all the way down. So even if I have a huge tree of files with thousands of directories and millions of files under the 2102 temp directory, this command is going to take care of all of them. It'll just delete all of them. Okay, now it's really important. Here's a fair warning. When you use the rm command in a terminal window, unless some special things are set up on your machine by default or otherwise, that permanently deletes the file. It doesn't tuck it away in some trash can where you can pull it back out. Okay, it's gone. Unless you go through extraordinary measures that are far beyond what we can do in this class to recover your file from whatever remnants of information are sitting out there outside of the file system data structure on your hard drive. For all practical purposes, your file is permanently deleted when you use rm. Okay, so let me show you the worst possible command to execute on a Unix machine unless you really know what you're doing. rm -rf, I'm almost afraid to type it, star. That's a terrible command. Because what happens is the shell expands star into a list of all the files in your current directory. And then the rm -rf deletes them all. So if you want to delete every file on your machine, try rm -rf star. I don't advise it. I don't advise even typing it. And I'm being very careful not to hit the enter key here instead of the delete key when I'm canceling out of this ill-advised command. It will literally permanently delete all the files on your machine if you're not careful. Okay, so a couple of more commands. So we've seen make dir and rmdir. We've seen rm -rf. Echo. Echo is a very simple command. It just echoes a string. Okay. If your string has spaces in it, you should put it in double quote marks. Okay, and you might think that's not very useful, but it turns out actually to be pretty useful because your shell maintains a whole bunch of information for you. Okay, part of that information is your current working directory, but it maintains a lot of other information too. So your shell maintains what we call an environment. An environment is a set of bindings from variable names to their, in this case, string values. And you can see what your environment is in Unix by typing print env. Okay, and I have all kinds of information in my environment. Some of this information is set up by, for my machine per se. When I install different pieces of software, often I need to set environment variables for that software so that when the shell launches that software can read from the environment how it should run, configuration variables or environment variables that influence how it executes. And so here you can see many different environment variables. Let's look at this one. There's an environment variable called path. And this is a particularly important environment variable to understand pretty soon. This path environment variable has as its value a sequence of paths. So /c/user/sully/mathlib/bin : that separates that path from the next path, /c/user/sully/bin : /ming/gw64/bin. That's where all the Unix commands are that you're accessing if you're running a terminal shell on Windows, /user/local/bin. This is where lots of user-installed software executables live. And you can see I have many, many, many different paths in my search path. We call this the value of this variable. This is my search path. Now remember back to the lecture on how the shell executes programs for you. The search path environment variable is incredibly important here, because when you type a command like ls, what your machine does is it pulls up your search path and then it looks in each of those directories in turn for a file called ls. And if it finds one before it gets to the end, in fact, the first one that it finds, it will then load in that file and run it. And that's why your search path, that's how your shell works, and it's why your search path is incredibly important. If you've installed some software on your machine and you try to run it and you get a message like command not found, probably there's a problem with your search path. Okay, there are easy ways to edit your search path so that it gets set to the appropriate value every time you launch a terminal window and a shell program, and we'll cover that quickly at some point soon. In fact, maybe even just about now. Okay, so that's the notion of environment variables. And now let's come back to the echo program and your shell. If I say, well, let me explain that. If I use $ and the name of an environment variable, the shell will expand that into the value of that environment variable. So if I wanted to print out my path, I can say echo, echo $path. The $ tells the shell to expand the value of the path environment variable into its value, which is that long string of paths separated by colons. And there, this is a great way to see what the value of an environment variable is on your machine. Look, here's another environment variable, home path, that points to my home path. This is a Windows path name, so it uses backslashes instead of forward slashes. There's actually probably maybe a problem with this, but that's neither here nor there. Okay, so that's the notion of environment variables, your search path in particular, printenv to print out all of your environment variables, and echo is a nice tool for printing out the values of different environment variables by using echo and a $ in front of an environment variable name. Again, the shell expands that environment variable value before it runs the echo program. So by the time echo runs, it's being passed the string value of that environment variable rather than just the name of the environment variable. If I say echo path, it's just going to print path. But if I say echo $path, it's going to print the value of the path environment variable. Okay, so that's a quick kind of introduction to Unix commands. Let's just practice a little bit. I'm at my home directory. Let's make a kind of a fake root directory called /. I'm going to just, I can't call it the character / because that has a special meaning, but I'll just call it /. Okay, I've made a directory called /. Let's go into that directory, cd/, Okay. Now there's no files in here. Let's create two directories like I talked about in one of the preceding videos. How about we call one etc. Okay, and I don't know, let's make one called bin. The etc directory /etc on a typical Unix machine contains configuration files for your machine. The typical /bin directory on a Unix machine contains programs that you can run. So let's go into the etc directory now and make two files. And we're not going to make real files here. We'll just make empty files. One will be called fstab, and we'll touch another one called, oh, I don't know, xyzzy. Okay, now let's go. We're in the /etc file. Let's go up one level to the / directory, then down a level into the bin directory. So you can string these things together to go up and down your file system tree. Okay, so now we're in, which is to say our current working directory is set to my home directory /bin, my home directory /bin. Okay, and in here, let's make a file. We'll call this one ls, and we'll make another file called rm. Okay, so we've made a kind of a little tiny model of what a little piece of the Unix file system looks like. Now let's go up to the / directory. If we do ls, we have our /bin and /etc directories. Let's make a data file at this level. So let's touch a file called readme.md, a typical name for a markup file containing text to be formatted nicely for presentation in a web page. Okay. So here we go. There's two directory files and a data file inside of a directory called /. Inside of bin, we have some fake Unix programs. /bin is almost always in the search path of a shell on Unix so that it can find all the kinds of standard programs that we've been talking about here. /etc has some other faked out, currently empty files in it, and readme.md is empty. Another command that's not on the slide, cat. Cat prints out the contents of a data file. So if I print out the contents of readme.md, well, there they are. It's empty. Okay, good. Awesome. I think it's probably worth spending 2 more minutes talking about editing of files. So we're in the / directory here. Suppose that I wanted to edit files within this directory subtree. Let's run VS Code using the code command. And that should already work for you. And use dot, which is current directory, as an argument to code. So we're telling VS Code to crank up a new VS Code window, opening up the current directory as its the project that we're gonna be editing. Now I'm gonna have to take a second. So I see VS Code now on my screen, but let me make that visible to you. And it will take me just 1 second to do that, if you don't mind. And we'll make that window a little bigger like that. Okay, and here we go. So, very good. Yep, here we go. Okay, so check this out. We opened up VS Code on the directory called /. Here's our bin subdirectory. Here's our ls and rm files, which are empty currently. Here's our etc subdirectory. Here's our fs tab and xyzz files. All of these are empty. Here's our readme.md file. If we want to edit any of these files, we just start editing. So a markup file has uses special characters to designate things as titles, for example, or subsection titles. And we'll just keep this. We'll just keep this very simple. Okay. So I've now entered some information into the memory of the computer, indicating what I want to store in this file. The information doesn't actually get saved in this file until I save this file. File save. Control S is the shorthand. You should learn that right away. You don't want to be using your menu if you can just hit Control S. So I just saved that file. Okay. If I look at this empty file and come back to this one now, it says, hey there. And if I go back to my terminal window, and now print out the copy, using cat, the readme.md file, well, now it contains that information that I stored in that file. So for now, that's all there is. And good luck. I'll give you a little assignment to give you some practice using these commands. So just stay tuned, and that'll be coming up shortly. Thank you.